Section 8.2 is on angles in polygons. Angles. We have interior angles and exterior angles. We talked about interior angles and exterior angles, I believe, with triangles. An interior angle would be these interior here. Exterior angles are these here. Okay. Okay, so let's look at these. It says the number of sides, the number of diagonals, the number of triangles, some of the interior angles, and some of the exterior angles. So we're going to go through this and talk about it. Talking about a diagonal is where you actually can connect one point, one vertex with another vertex without it being a side. Okay, so I cannot do that on a triangle. The number of diagonals on a triangle are none. There are no diagonals. The number of triangles in a triangle is 1. We know that the sum of the interior angles of a triangle is 180. We've done that many times in the past. The exterior angles, the sum of all these exterior angles of a triangle, is 360 degrees. Okay. All right, let's move on to a quadrilateral. We can connect a diagonal from one vertex to another once, making two triangles. So I've got one triangle, two triangles. So there are one diagonal. The number of triangles it makes is 2. The sum of the interior angles, since there are two triangles, is 2 times 180. So there's 360 degrees total of all interior angles of a quadrilateral. The sum of the exterior angles of any polygon is always 360. So if I took and added all these up, all these, they end up 90 degrees in this case, and there's 4 of them. 4 times 90 is 360. They always add up to 360 degrees for exterior angles. Pentagon. 5-sided figure is a pentagon. I can take a diagonal from one vertex twice to other vertices, giving me 3 triangles. 3 times 180 is 540. The reason I take 3 times 180 is because there's 3 triangles and there's 180 degrees in each triangle. So the number of diagonals is 2. The number of triangles is 3. The total sum of all the interior angles is 540. And just like I mentioned before, the exterior angles are always 360. 6-sided figure. You should start seeing a pattern. A 6-sided figure, you can draw 3 diagonals from one vertex, giving you 4 triangles. So 3, as you notice, it goes up 1 every time. It's always 3 less than the number of sides. The number of triangles is always 2 less than the number of sides. We take 4 times 180. We always take the number of triangles times 180. In this case, we get 720. The exterior angles are always 360. So we start seeing patterns with all of these different polygons. Now, here's the thing. If we have n sides, now we know the number of diagonals is always n minus 3. The number of triangles is n minus 2. The number of the sum of the interior angles is n minus 2 times 180. And the sum of all the exterior angles is always 360, no matter what. Okay, so talking about angles inside of a polygon, you should be able to decide how many there are or what the sum of them are by the number of sides using these patterns. Okay, so here's exactly what we just talked about. It says the sum of the measures of the interior angles is n minus 2 times 180. Find the sum of the measures of this one. Well, the first thing we got to do is count. 1, 2, 3, 4, 5, 6, 7. There are 7 sides. So the number of triangles inside of this is 7 minus 2, or 5. The sum of the angles, interior angles, is 5 times 180, which is 900. It does say heptagon, which is 7 sides. Okay, so now we know how many sides there are, and we know then how many degrees adds up to. I believe this is a heptagon as well. Nope, this is a hexagon. There's only 6 sides here. We said 6 sides gives us 4 triangles. So 4 times 180 is equal to 720. So all of these have to add up to 720. So if we take 720 and we subtract all of the sides added together that we have, that should get us this last angle. So x should be equal to this. So it's the total sum of all the angles minus all of the rest of the angles added together. So that would be 720 minus, I might have to use my little handy dandy calculator here to make sure I got it. So 88 plus 142 plus is 607. So that looks like 113. Which looks like 113. It's a little more than 90 degrees, so it looks correct. Find the measures of the interior angles of a regular octagon. Now it's kind of nice. If it's regular, you know all the angles are the same. So we find the total sum, which is, there's 6 triangles, so 6 times 180, which is 1080. Then each angle, since they're all the same, we can take 1080 divided by 8. If I take 1080 divided by 8, it's 135 degrees apiece. Okay, so find the measure of the interior angle of a regular octagon. Well, all of them add add up to be 1080 using our pattern. And then each angle we divide by 8 because there's 8 of them, get 135 apiece. Okay, so here you should be able to find this last angle, here, here, and G here. And then find the measures of the interior angles of a regular polygon with 12 sides. So go ahead and pause the video, try those 4 problems, and then I will go over them here when you're ready. Okay, welcome back. The interior angles of this one, there's 5 interior angles, so that means it's a pentagon, 5 sides, means there's 3 triangles, so 3 times 180 is 540. So we have 540 minus those 4 sides, 111 plus 118 plus 130 plus 109. So we go ahead and use the calculator. We have 540 minus 72. So G is 72 degrees. Okay. This one is a quadrilateral. We know that that's 360 degrees, the sum. So that's 360 minus 103 plus 133 plus 58. $66 degrees. Okay. And again, I'm going to add all these up and then subtract it from the total sum. So I'm going to add all those up right now. So I got 140 twice. I've got a 90-degree angle right there. So they all add up to 770 degrees. The total sum, there are 1, 2, 3, 4, 5, 6, let's see, count again. 1, 2, 3, 4, 5, 6, 7, 7 sides. We already figured that out. That was 5 times 180, which is 900. So that would be 130 degrees. This is 130. Okay, find the measure of the interior angle of the regular polygon with 12 sides. Well, we know the sum is 2 less than 12, so that's 10 times 180, which is 1,800. But then we divide by 12. So each one, 1,800 divided by 12. 150 degrees. Exterior angles, where you just mentioned exterior angles at the beginning, they all add up to 360 every time. Here's the theorem that talks about that. So no matter how many there are, they add up to 360. Since we know they all add up to 360, we know 85 plus 95 plus x plus 2x is equal to 360. We can plug into our equation. We've got 180 plus 3x equals 360 minus 180. 3x is equal to 180. X is equal to 60. try to find values of x for these. Pause the video, work it through, and then I'll show you how to do it here, then verify your answers when you're ready. Okay, welcome back here. We've got 73 plus 60 plus 46 plus x is equal to 360. 106, that would be 179. So 360 equals 179 plus x. One I forgot. I forgot the 90 here, so I have to add that with it. So that's actually plus 90. Add 90 to that, I get 269. Minus 269, I get x is equal to, that would be 91 degrees. 91 degrees. If I add these up, I get 3x plus 116 plus 89 would be, I'm going to go ahead and just add them quick. I could do this in my head, but we'll quickly put this on the calculator. 297 equals 360. So 360 minus 297 is 63. So x is 21. Here we've got 2x plus 110 equals 360. They all add up to 360 even though there's only 3 of them. Minus, I get 250. X is equal to 125. This one, we've got 70 plus 75 plus 65. We have 5x plus 210 equals 360 minus 210. I get 5x is equal to 150. So x is 30. And that's it for 8-2. Lots of calculating. Make sure you put your equations on your paper and show your work so I know everything's going well for you.